Hello everyone, welcome to the channel. Microsoft has just dropped OmniParser. Just yesterday I covered one of the features of newly released Claude Sonnet 3.5 model where it can understand your screen and your computer use, and then with the help of some object detection on the screen it can perform a lot of tasks. It seems that this has become a new frontier, at least this week, when it comes to AI. And now we have OmniParser, which is a very interesting project from Microsoft. OmniParser is a general screen parsing tool which interprets, converts UI screenshots to structured format, and this is what it does. So for example, if you look at this screen, on the very left hand side we have a screenshot of the screen or home page. From there it has detected the model. OmniParser has detected all of these boxes. It has overlaid some of the numbers on top of those bounding boxes, and it has given us some of the description about it. Similarly, the next screen shows you the same. And if I show you another example, again, this is a PowerPoint slide where it has created bounded boxes around the elements of the page, and you see there are a lot of them. And then it has described them with text box, icon box, and then also a small description as what exactly that UI element on the screen is. In this next example, there is a projects um, folder where you can see that there are maybe it's a Microsoft project where it has again identified a lot of UI elements on the screen, and it has given us the overlay number on top of it, and on the very right hand side it has described it. So this model can be used as a standalone too, of course, but I think the more value comes out if you use it as a plugin or as a sidecar model with a bigger model like GPT-4 Vision or any other vision model, where this model will detect the object, give it a little summary, and rest of the thing will be done by the other model. But you can definitely use it as a side, as a standalone one. So in this video we are going to install it locally, and then we will see how it works. But let's have a bit more discussion on this model. Also, before I go forward, let me thank Massed Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on good prices, I will drop the link to their website in video's description. Plus, I am also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. Now, this OmniParser includes a fine-tuned version of very famous YOLO model. If you don't know what YOLO is, YOLO stands for you only look once. YOLO model is a very famous model. It was released in 2016 and it is used in object detection, and especially when it comes to real-time object detection. Over the years there have been a lot of YOLO models and versions, and recent one I believe is YOLO version 8. And this model OmniParser includes a fine-tuned version of YOLO version 8 for object detection, and then a fine-tuned blip 2 model for captioning and stuff and bounding boxes and other related things. And this OmniParser is designed to be able to convert unstructured screenshot image into structured list of elements, including interactable regions, location, and captions of icons on its potential functionality. And normally it is intended to be used in settings where users are already trained on analytical approaches and critical reasoning is expected. So as I said, you should be using it on various screenshots, maybe on PC, on phone, and there are a lot of use cases which I could think of where you can easily use this model. Okay, enough talk. Let me take you to my local system where I'm running Ubuntu 22.04. Let me quickly show you my operating system, and let me also show you my GPU card where I'm running NVIDIA RTX A6000 with 48 GB of VRAM. So that is done. Let's try to get this thing installed locally. So let me install it. Let me first create a Conda environment, and I'm going to go with Python 3.12 this time. Normally I go with Python 3.11, but This model requires 3.12 as per their GitHub repo, and I will drop the link to it in video's description so that you can also try it out if you like. Next up, let's install all of these prerequisites, which include a lot of things: torch vision and stuff. You can find it on their page. This is going to take 3 to 4 minutes, so let's wait. All the prerequisites are done. Next up, let's git clone the repo. That shouldn't take too long. That is good. And now I am going to create and launch my Jupyter notebook where we will play around with this model. Now let me quickly launch it. And the Jupyter notebook is now launched. Before we proceed further, we need to download models. For that, you would need to go to this OmniParser's website or repo on Hugging Face model card, and I will drop the link to it in video description. Once you go there, click on files and version, and first you would need this model, which is best.pt in icon underscore detect folder. This is one file you would need, and then you would need to go back and you would need this whole folder of icon underscore caption for underscore blip. So this is our blip model, and the other one was our YOLO model as I described earlier. Now you can just download it and put it in anywhere in your local host. I already have downloaded it here. So what I did, I just went into my home directory. I created this my model and I downloaded everything there as is. And once you have that, go back to your notebook, and then from there import the libraries and refer to this model path there. Also, I'm going to give you the link to this whole command, so don't worry about these commands. So let me run it, and it is initializing the YOLO model, as you can see. So our YOLO model is done. Next step, we need to go and get our blip model. For that, again, I'm just giving the path of that directory and downloading it. So let me run it, and there you go, it is being downloaded. So it's being initialized with all the preprocessors and tokenizers, and that is also done. And the blip model is done. You can also check the model type here. You see that it is saying it is YOLO and it is on the CUDA device. Now, in order to do the inference, all you need to do is to do this. And don't worry about the length of the code. Let me try to explain. Sorry, let me go down here, just scrolling down. Sorry. Okay, so I'll just go here, scroll a little bit up to show you what is happening. So you see, platform is PC, which means it's this system. Now this will best work on Windows, but I'm on Linux, but I can show you what is happening here. And then from you can go with PC, you can go with any web page, or if I scroll down, you can even go with the mobile device. And then it is doing the bounding boxes, and then it will detect the image. I already have that image here. So if I just go up, I have just given it the image from my local system. Let me also go to this directory and show you. So this is the image on my local system, which I'm giving to the model. Okay, so let's try it out. I'm just going to run it. And there you go, it has processed that image. It was very quick, like 85 millisecond. And if you want to see the label coordinates, you can simply run it with this. And it is going to give you all the labels of that image. So if I just quickly scroll down and keep going down, there you go. You see, these are all the text boxes and stuff on that PowerPoint one. So there you go, this one, all of it, it has done it. And I believe we can also display the image something like with by plotting it. So if I run it here, there you go, you see, it is showing us all of it with the overlay numbers and the description of them. How good is that? Amazing stuff. And you can see that once you have this sort of functionality, you can just patch this model up with any other model or even tool to do a lot of stuff. There could be a lot of use cases for your mobile phone, object detection and screen scraping, or web, and also your PC. And I hope that you enjoyed it. While we are at it, let me show you a similar tool which is also the sponsor of this video, AgentQL. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. You can use the Python SDK to run your queries in production using Playwright and use the browser-based debugger for optimizing queries in real time on any web page. AgentQL is quite a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. And I will also drop the link to their website in video's description. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.